Hello everyone, I'm going to show you how to convert a disused office chair or a damaged one or even a new one if you would prefer into a very competent Hotas setup. Now using this 3D printed parts which I sell in my Esty and eBay store, you could convert your used chairs into a very competent Hotas setup for your Hotas system. I'll show you how I did it and show you all the parts that are necessary. Most chairs would have this bottom, and this is what you need to use my current design to convert into a Hotas setup. As you can see, my chair is damaged. There's a big crack on the handle, so it's lacking one of the handles. This is still in good condition on this side. So it's a spare chair at home which I'm going to convert into for use on my Hotas for playing squadrons. Now you see the two bolts where the subframe is attached to the seat. Those are the two bolts you would need to take off, but I'll take it off now and show you how all the parts shown previously fit in to convert this to a very competent Hotas setup. As stated, this is the main subframe. I've taken off the bottom seat, so you could see that the rest of the seat is supported in two parts. This comes standard with most seats, but you need to check yours. But at a minimum, the seats will come with this bottom, regardless of how the back section is. But it will come with a bottom similar to this, because due to mass production, all or most seats are made with this same subframe and this pneumatic suspension system. So they are all designed in this way. What's most critical to you is the two bolt holes in the front. This is the seat. This is the seat as taken off. So those are the four bolt holes where the seat is connected. How the seat is connected to the main subframe. But what's more important, like I said, is the two front bolts. I took off all the bolts just for demonstration, but you only need to take off the two front bolts to slide in the main metal bit that holds the Hotas setup together. Okay, just for reference, I don't know if you can see this, but the centers, about the centers of the holes, about 150 millimeters apart. So that's what centers are used for the main support structure. Okay, so these are the centers. The main support structure is this metal bar. It's a 90-degree metal bar. So it will have holes drilled 150 mil apart, just enough to allow you to see the 30 millimeters angle iron bar of a specific length. It will be drilled 150 mil centers, two holes, which will fit in the chair. As you can see, the system used here doesn't compromise the safety of the seats. It just uses the bolt holes, and these are not under tension. The bolt holes are not under tension. They just as locators to keep this metal bar in place. So that's the metal bar, specific with the holes drilled in. Okay, at this point the seat has been put back in and all the four bolts have been tightened up. Just this one remains. I'll tighten that up now. But that's what happens with the 90-degree bar. It goes in and it's merged with the seat in the location that was shown previously, and all the four bolts are now inserted. Normally, if you are doing this at home by yourself, you would just take off these two bolts, slide in this bit, the metal bar, and torque it up as far as the holes have been centered properly, which they would be if your chair should be a standard seat. So that's the step. Once you have this bar in, you torque up all the bolts and then proceed to the next step. After all bolts have been torqued up, the seat is back together as it should be, and the bottom will look like this with with the bar extending on both ends. As you can see, you can leave the seat like this without adding any other bits, and it will still be almost like a standard seat with with the bar not causing any interference, so it won't cut you or anything like that. It will be all filed up at the ends, but then it's still not in your way. So the seat could be used similarly to this. Having this bar in place doesn't affect the safety of the seat, as nothing is in tension. Well, the bolts are in tension, but the bar just remains located in the position by the bolts. So that's how it would look when you're done. So on to the next step. This is the next step. These two 3D printed, specifically designed parts are made to fit into the 90-degree bar above. They have these insets. There's a left hand side and a right hand side of each, with a locking pin which could be made to be drilled into the bar to lock this in place, and the additional port at the bottom. But that's the next section that would go into the bar on both sides. So this side has been slid on onto the bar. As you can see, it's now supported based on the profile it's made. These sections, both of them are made out of PETG. PETG is certain material that has some give, so it will allow for torsion, because these sections are in torsion, or would be in torsion when being used. Now they are not, but when being used they will be in torsion, and PLA might not work as good on a long term while in torsion, as it is more brittle than PETG is in this case. So these two items are built of PETG. That's the locating hole. You could have a drill point made to locate it in place, but that's how it would look once you've installed this bit in. I will push this back in, so you see how it slides in and out. You could easily just slide it in and out, and you could drill some holes in the 90-degree bar to get you a locating point for this, because depending on how wide or how you want to set up the Hotas, you could pull this out a bit more to get a wider seat or stance, or push it in, so it slides in and out very easily and allows you to locate the main support structure. I'll swivel the chair around to show this bit. This is the main table for the Hotas. That's where the last and final bit goes in. It also has locating pins and can slide in for adjustments of how far you want this to go or how close. And then this pin could be used to lock it in with a screw or something. I could 3D print something for as a locking pin, or you could use a standard locking pin, which I would send also added. So that's what supports the Hotas system. And this section, the black section, is made of PLA because it's mainly rigid and mostly under some tension, some torsion, but more it has a support connecting point built in to allow it to contain a bit more or take a bit more stress, because this is the main area. So now I'll set up my own Hotas for you to see. But that's it. It slides in and out very simply and can be locked into place based on what your set points would be. That's the other one. So it's a very simple design. And that's the view on both sides. Okay, the main support base for the Hotas stick and throttle would be this black piece. It's been designed to take the loads and transmit the loads to the other structure by the seat. But this is my Thrustmaster 1600M. It's already been tapped and drilled. This hasn't been. This is new, but this has been tapped and drilled. You can see the holes that take the, I believe it's an M8 bolt that goes straight into the thrustmaster on the locating points built. So no modification has been done to the 1600M. It's a standard 1600M with no modifications done to it at all. It's just the drills. You can see I even made some mistakes, but obviously whatever Hotas system you have, you could send me dimensions and I would drill it ready, or you could drill them and tap them into to fit yours also. It holds the Hotas in place. It doesn't move once you have tapped and drilled. Once you have drilled those holes and installed the two screws on the two different locating points, and that's what you have in the end. Okay, so this is another view of it being connected. So that's the 1600M, both the throttle and the stick on both sides. And as I said, you could slide it through and adjust it and then link it with a locking pin at whatever location you want or you feel is, so it's adjustable both in width and in length to give you the best grip or the best level of comfort. That's the other section. The throttle, the same, you could adjust it and lock it in your preferred location. That's 1600M. You could convert any seat. A very simple design, no major parts in tension. You can support a large amount of weight. I would do some tests on the limits and put that down of what it can support, but it's definitely more than what is required to support the Hotas system. Okay, this is a look at the 3D printed main base plates, the dimensions for the base plate. Now this part could be modified to suit whatever Hotas base you have. But this current base plate fits the Thrustmaster 1600M. So it's 146 millimeters wide by 180 millimeters length. So that's the main base plate. But depending on what the customer wants, or depending on what Hotas you have, you could request for a different size base plate. Obviously there will be a cost to do with that. The height of the base plate is about 10 centimeters, or obviously that could also be modified to suit whatever heights the customer requests for. But that's the current base plate design, and that could be modified. The standard pieces for the connection bits would be standard for everyone, or could be made wider depending on what you want. So that's the base plate and the modification that could be done.